Morning, Integrated 2. Today we're talking about circles, and part of your assignment today is to read and take notes on 19.1, with the exception of something called Explain 3, that is titled Investigating Inscribed Angles on Diameters. Don't bother taking notes on that, but take notes on the rest of it. But there's a couple things that we need to talk about first. First of all, this is a circle and has a center, and a lot of times it's circle C, and we literally call that circle C, or it could be circle P. I don't know why. I know why C is used a lot because it's called a circle, dude. But P, I don't know why P is used a lot, but it seems like we see circle P kind of a lot, and circle C. Something else we need to know is that there are 360 degrees in a circle, and that means all the way around here is 360 degrees. But I also want you to realize that right here, there's also 360 degrees, So there's 360 degrees right around here, around the center, and around the edges of it. That's really important because what we're going to be dealing with circles a lot is this what we would call central angle, and how that affects other angles and how you can use it to find other angles. So for instance, what if I call this circle P now, right? Well, if I divide this right down the middle like this, well, that of course means since there was 360 degrees in a circle, that from here to here, I'll call this from A to B like this right here. I am going to put a little C right here. I'll explain why in just a second. But from here all the way to here, that would be 180 degrees. And that's also true right here. From here to here is also 180 degrees. And that's really an important concept to understand. But then we can take it further. What if I go this way like this? And I make this a right angle? Well, clearly this is 90 degrees. But then if I put a little d here, wouldn't this also be 90 degrees? And that's because, again, there's 360 degrees in a circle. From here to here is half a circle. That's half of 360 is 180. Isn't this a quarter of a circle? And isn't 360 divided by 4, isn't that equal to 90? So that's kind of where we get to. And what we're talking about is the measure of a circle. So the measure is like this is 180 degrees, and from here to here is 90 degrees. Now, let me get back to something here. What if we talk about just this one right here, this is called an arc. From here to here, I'm just going to erase this and replace it with red. From here to here is called an arc. And you might recall this was a letter D that I had right here. And we're interested in the measure, make sure you can see that, of arc AD. Did you see that little arc thing that I made? That's called an arc. And what is the measure of it? Well, of course, it equals 90 degrees, as we said right here. What is the measure then? This is interesting. What is the measure of arc ACB? Well, ACB, this measure is half of a circle, which is 180 degrees, which, by the way, that is called a semicircle. Anyway, you're going to learn a lot more about this stuff as you read and take notes on 19.1, but I kind of wanted to give you a heads up. We're going to be dealing with arcs, and we're going to be dealing with central angles. Look, this is a central angle. We'll talk more about that in a second, and their measures. So this is kind of what we're doing in section 19. Read and take notes on it. You'll learn some more. Let me pause for a second. Come back. All right, so here we're back. I want to talk to you about two things, central and inscribed angles. This is in your notes, but I want to talk to you a little bit about it. Don't you love my beautiful circle? It was supposed to be a little more circle-ish, but it is what it is. Well, first of all, I want to talk about is that we'll call this circle P again, and this is the center of the circle. And if I take that center and I draw two radii being plural for radius, so radiuses, if you will, then what I've just done is I've created something called a central angle. Pop quiz, why is it called a central angle? Well, it's called a central angle because the vertex is in the center. And something interesting about this, let's see, let's first estimate this. What do you think this is? What is this, 80 degrees right here? Maybe, is that an 80-degree angle? Sure, 90 degrees would be like that. Yeah, sure. Well, what that means then, and this is really important, is that if I have A here and B here, what is the measure of arc AB? Well, it turns out to be the same as this central angle. This is 80 degrees. So not only is this angle here 80 degrees, but so is this right here. This whole arc is also 80 degrees. That's 80 out of the 360, okay? But then there's something else called an inscribed angle. So that's a central angle. Here's an inscribed angle right here. Check this out. Notice the center of, or not the center, the vertex of this angle is not in the center. That was a central angle. But when the vertex is on the circle, we'll just say on, then this is something called an inscribed angle. An inscribed angle. And what's interesting about this, and it probably kind of looks like it, like think about this. Look at this angle right here, and then look at this angle here. If this is 80, this looks to be smaller, and in fact it is. This is 40 degrees. This is the inscribed angle theorem that you'll read and take notes on. But effectively what we're saying is this angle is half of that arc. Or vice versa, this arc is twice as much as the angle. So to review, central angles have the exact same measure. This angle here is 80, and so is the intercepted arc. That is the arc that these two radii intersect. But what about the inscribed angle? An inscribed angle is half of the intercepted arc. Notice they both intercept the arc at AB, so something to watch out for. We're going to use this a lot in problems to figure out the measures of things, all right? So I'm going to pause real quick and come back to you. All right, here's an example of a type of problem, and these get a little bit confusing, so watch what I'm going to do and listen to what I say. What's our goal? Our goal is to find the measure of arc AB. AB is from here to here. I need to know how many degrees is this. There's 360 degrees in a circle. Of those 360 degrees, how many degrees is this? I'm going to point a couple things out to you that I want you to see. The first thing I want you to see is that I'm only giving you this 30-degree angle right there. This arc AD is 30 degrees. Well, doesn't that mean that this central angle here is also 30 degrees? Now, right there, I want you to remember something called vertical angles. Aren't these vertical angles right here from geometry? If this is 30 degrees, that makes this 30 degrees. And if these two are 30 degrees, isn't this arc also 30 degrees? Now, that's not really what I'm looking for, but it's going to help me find what I'm looking for, because now watch what happens. Isn't it true that I just want this arc right here? I want from A to B, but now I want you to see this. Look at this AC. Isn't AC a diameter of the circle? Which means this whole thing from here all the way to here is a semicircle, and that is 180 degrees. From here all the way to there, arc ABC is 180 degrees, and I know that because it's a half a circle. This is a diameter and it cuts it in half. Well, wait a minute. Doesn't that mean then that arc AB is 150 degrees? Where did I get that from? Well, look at the colors. I see the green is 180 degrees, but I've got this red arc BC, which is 30 degrees. Wait a minute. So if I have 180 and I subtract 30, that means this part must be 150. These are the kinds of things you're going to look for. I want you to look for diameters, because that's 180 degrees, and I want you to look for vertical angles. If you keep those two things in mind, today's assignment's going to be a little bit easier. Okay, wrapping this all up. This is your homework, 19.1, 1 through 17 odd. Now, I want to remind you that the odd answers are in the back of the book, so you might want to take a look at those and see if you can figure out how they did it before you ask me questions. Then if you can't and you're struggling, send me a text, ask me a question. The best thing you can do is to send me a picture of what you're doing so I can analyze it and see what you're doing wrong and kind of point some stuff out. So, hey, give this your best shot. Okay, we're going to work on this week, and we're going to get lots of practice because it is a little bit complicated. Once again, I hope you're doing well, and we'll talk to you guys soon.